Hi everyone, Mr. McIntyre here. Today is 2.6 on solving proportions, and let's start off by just talking about what a proportion is before we even talk about how to solve them. So a proportion is a comparison. It's a way of comparing two things in math. Now specifically what it is it's two fractions or two ratios that are equal to each other. So here's a couple examples of proportions. Number one, 1/2 or 1/2 equals 2/4 or 2/4. Now that's true. 1/2 does equal 2/4. If you take 2/4 and reduce it, you get 1/2. But that's one example of a proportion. It's two fractions that are equal. They're the same. Now, the ones we're going to be working with aren't just going to be numbers. They're going to have variables in it. So here's another example of a proportion. X plus 5/2, that's one fraction, equals x over 8. That's another fraction. So that's a proportion with variables in it. Two fractions equal to each other is what we call a proportion. Now there's a trick for solving proportions. To solve proportions, we do what's called cross-multiplying. Cross-multiply. And it's kind of exactly what it sounds like. You're multiplying across diagonally the equal sign. So basically you take the top of each fraction and multiply it times the bottom of the other one. You have two separate multiplications. It makes a big X through it. So you cross multiply top of each one times the bottom of the other. That makes a new equation that you then solve. So let's try it out. Here we have a proportion. We're going to solve for x. We have x over 32 equals 3/4. So we are going to cross multiply. So the first one here, and I like to circle to show what I'm multiplying. This is what we mean by cross multiplying. You take the top of one fraction, the x, times the bottom of the other one, the 4. So I will have x times 4. Then you do the other ones. The top of the other fraction times the bottom of the first one. That would be 3 times 32. Then what you do is you make a new equation. Those two things will always be equal to each other. The top of one fraction times the bottom of the other will be equal between the two fractions. So basically x times 4 is, let's see, what did I do wrong? 3 times 32, not 3 times 2. That's better. Okay, x times 4 is 4x. We'll leave our equal sign. 3 times 32 would be 96. Now to finish solving, it's just a one-step equation. I'm just going to isolate x. So I have 4x, or 4 times x. I'm going to use it divided by 4 to cancel it. So we solved for x, we isolated x. My answer is 96 divided by 4, which ends up being 24. So final answer there is x equals 24. Now you can see I kind of color-coded the beginning to make it easy to stand out. The yellow, x times 4. The blue, 3 times 32. That's the cross-multiplying part. You do this diagonal, and then you make a new equation by multiplying. Let's do one more. X plus 1 over 3 equals x over 4. Let's do the cross multiplying again. So this time I'm going to multiply those. I have x plus 1 times 4. Now the x plus 1 is one thing, so I'm going to use parentheses. It's actually going to end up being distributive property. I have x plus 1 times 4. I'm going to put the 4 out front instead of after it because that's where I like it for distributive property. And then for our other one, we have x times 3. We are going to make an equation out of those again, and then we'll solve it. So right here, let's start with the distributive property part. I have 4 times x is 4x. plus 4 times 1 is 4. And that equals x times 3, which would be 3x. So now all of a sudden we're on like a homework question from the last section. There's two different x's. We have a 4x and a 3x. We want to get rid of both of, or get rid of one of them. Here's a little trick though. Normally I would probably, actually, you know what, let's do it that way. Let's subtract 3x from both sides. I like to get rid of the smaller ones so you don't have to deal with negative numbers. Let's subtract 3x on both sides, as always. Now I lined it up under the 4x. I always line up my like terms so you can subtract from them. Now what I have, 4x minus 3x is 1x. Now when you have a 1x, I usually just put x. You can put the 1 there if you want, but I'm just going to put x. Then we have a plus 4 that drops down, and it all equals 0. See, the 3x minus 3x, everything cancels. If everything cancels on one side of an equal sign, you get a 0. So I have x plus 4 equals 0. I'm going to recopy it up here because I'm out of space. Now I can solve it by subtracting 4 from each side. Our goal is to isolate x. So I'm going to do a minus 4 on both sides of the equation. The plus 4 and the minus 4 cancel. The x drops down. And for my final answer, 0 minus 4 is negative 4. So your answer for that question is negative 4. But it all started with the blue and the yellow again, cross multiplying. I did x plus 1 times 4. I did x times 3. I set those two things equal to each other, and then I solved for x. All right, the last part of today's notes is I want to show you what this looks like in a word problem. So here's our last example for today. We have a word problem. It says an orange tree grew 7 inches taller in 2 months. How much taller will it grow in a year? So this is at the very beginning of notes today. I said a proportion is a way of comparing two things in math. So we're comparing how much this tree grew in 2 months to how much it's going to grow in 1 year. So I'm going to make a verbal model. Remember in Module 1 we talked about verbal models, when you kind of put into words what you're going to do. I'm going to make fractions by putting growth on top and the time that it took to grow that much on the bottom. So I'm going to make two fractions and I'm going to set them equal to each other. My first fraction, 7 inches is the growth, 2 months is the time. Now for my second fraction, how much taller will it grow? We don't know its growth. That makes it the variable. I'm going to call that x. And for the time, it's 1 year. But I'm not going to put x over 1, because remember, we also talked about this in Module 1. If one thing is in months, the other thing has to be in months also, or years. It's got to be the same. So I say to myself, well, let's see, a year is 12 months. So if the tree grew 7 inches in 2 months, then really what I want to do is figure out how much it's going to grow in 12 months. So my first proportion says the tree grew 7 inches in 2 months, 7 over 2. And my second one says the tree is going to grow x inches, which is what we're trying to answer, in 12 months. And right there, that's your proportion. Now you solve it just like the ones we did earlier. You cross multiply. So I have 7 times 12. I have x times 2. Set those equal, and we'll figure it out. Let's do the multiplying first. 7 times 12 is 84. X times 2 is 2x. So you can figure this out by dividing both sides by 2. We want to isolate that x. We're going to divide by 2. 2 cancels with 2. X ends up equaling 84 divided by 2, 42 inches. So basically what we're figuring out here is if our orange tree grew 7 inches taller in 2 months, then it would grow 42 inches taller in a year, as long as it keeps growing at the same rate. But the idea of this question is what I wrote in first green, then yellow, then blue. We have to be able to read a question, read a word problem, create that verbal model, decide what you're doing. I made ratios or fractions by doing growth over time. I made two of them, set them equal to each other, that's my proportion, and then I cross multiplied and solved.